Okay, so if you listen to the videos I posted previously, I'm actually starting over, going to do things a little bit differently, going to go into a bit more detail, still keep it at a pretty high level overview, and I'm breaking things up into much smaller segments, so I'm going to try and aim for 15 minutes for this video. I don't know that I've ever been able to really hit my target, but we're going to see. So what is this all about? It's a series of videos that's just going to touch on a lot of the major points that you'll encounter when doing web development. So here is a subset of the terms that will come up. There are a lot of technologies involved in web development. A lot of people have been doing it for a long time. A lot of big companies are involved. And so I'm going to hopefully be able to go through the major pieces, how they connect, kind of tell a story so that when you learn a new technology or look for something to fit in, you'll know how it fits into the larger picture. In particular, I may try and go into a little bit more detail on C# technologies and frameworks, but I'm not going to get there yet because to start with, we really have to deal with the browsers. So let's take a look at what our objective is for any kind of web development. This is basically the path that we're going to follow for any sort of website. The key here, browsers are essentially a way for a remote server to have a user interface. The challenge, of course, is that you don't want to be downloading 50,000 applications and running them, so you have the whole internet, and you have websites which you go through and browse them, and the browser is your user interface. So you have a server that is somewhere not located by the user usually, off in the distance. There's the internet, the browser, and then the user. So the user wants to either access content on the server or modify content on the server. And I represent the server here as a single box. In reality, this could be its own cloud. You may not be talking with a single server. A single web request may interact with multiple computers. We'll touch a little bit on that at the very end. But for now, let's just go ahead and assume that it's one server. So if you know some basic networking, you know that there's ways to connect to servers over the internet and send data back and forth. And there are plenty of games and applications which wouldn't be considered web development. So if you take a lot of your online games, it's a popular one. Fortnite is not web development per se. It may share and take advantage of a lot of the pieces that we're going to talk about. But when I talk about web development, I'm really talking about using a browser. So I would disqualify Fortnite because they're not using a browser. That means, for example, they don't have to use HTTP. They have a whole lot more low-level control over how their code runs, and we'll go over what that means as we go on. So this is the problem we're trying to solve. If you're not interested in this problem, you can stop watching now. Hopefully over the series of videos, you'll understand how this works today. So let's go ahead and visit a website. And I'm using Chrome. I'll use it for all the videos just because I'm most familiar with it. One of the most useful things, all the browsers have it, if you're doing any kind of web development, is going to be your developer tools. And they look more or less the same and have more or less the same capabilities across Edge, Chrome, and Firefox. And so I almost rarely get there that way, but just showing that off. Usually I just go like that to open up. And as you can see here, the site Stack Overflow, we can get a lot more information about what this site is. And right here, we're looking at the DOM. So let's actually go ahead and talk about that. So the first video is going to be covering presentation. And by presentation, if you're thinking MVP, like a model view presenter, presentations being like a console presentation versus a GUI presentation, it's the same concept, but I'm not talking about that specifically. When I say presentation, I'm really talking about how do we turn data into pixels that the user is going to view. How do we render things to the screen? And for the web, 90% of the things that you're going to find out there are going to be using HTML and CSS. In the past, there were applets and there was Flash. Both those things are dead now, so I'm not even really going to bother going into any kind of detail about them. Alternatives, there's Canvas, there's WebGL. There's probably something I missed, but again, 90% is HTML and CSS. And so a lot of times this may even be masked from you. For example, if you were doing Blazor, maybe you never write any actual HTML files, although even then I think you're writing something pretty similar. But at the end of the day, when you're doing Blazor, client-side or server-side, WASM or not, you're probably still generating HTML content, which is getting displayed in the browser. HTML is the GUI language of the browser. HTML itself is really basic. It's a set of elements. It can be extended with CSS and JS. It's a tree-like, XML-like structure. I mean, we'll just look at a quick, what are we going to start with? Yeah, so here's just a very basic HTML page. You have these elements here. It's not technically XML because a few of the HTML elements do things that's not strictly allowed in HTML, mainly like self-closing tags. So you can do, I've got a broken keyboard. That is valid HTML. It would be invalid XML. XML would say it should really look like that. And of course it's complaining because that's not necessarily valid HTML. There's XHTML, which is XML compliant HTML, but that's not really anything anyone cares about anymore because no one uses XML anymore. So just know that HTML looks a lot like XML, but it's not actually XML, and you'll be fine. If you're just sticking with HTML, you're going to make really simple sites. So here's Wikipedia from when it first started. This was just, you could make a site like this with raw HTML. You wouldn't even need any CSS. This is just plain old HTML. But in reality, there's going to be lots of JavaScript or CSS that's beefing up your HTML, or both. And we'll talk about each of those in detail. And maybe it's not JavaScript these days. Maybe it's WASM. So let's go ahead and let's talk about the DOM. So these two terms will get used interchangeably a lot. When someone's talking about HTML or the DOM, when they're talking about a web page, they might talk about, oh, what's the, I use an API to interact with the DOM, or JavaScript allows you to interact with the DOM and manipulate the DOM. So what are they talking about? DOM stands for Document Object Model. It was a long time ago a sort of standard API for manipulating both XML and HTML documents. But basically the idea is HTML is kind of the file format, if you will. It's the syntax for what elements you have. The DOM is the in-memory representation of objects. So if I'm viewing this website here, I'm viewing this HTML. This is a text thing here. This is actually a text representation of the DOM. But this is really in memory somewhere. There's a bunch of objects that each of these things represents. That's the DOM, the actual in-memory page that you're viewing. And the developer tools give us this interface here so we can kind of inspect the DOM, manipulate it. So we can change that like that, and then it'll change it on the screen. This is, of course, not changing anything on the server side. We're just changing, this is what's in memory on the browser, on the user's PC. So normally, when you're looking at a page, the HTML, if there are any HTML files, there may not be any HTML files. You could make a page. I mean, you need some basic outer level HTML, but 99% of the content could be dynamically generated through JavaScript. But basically what I'm trying to get at is the HTML files that you have don't necessarily match the DOM that you're looking at any given point in So do an example of what I'm talking about here. Look at our example here. Let's go ahead and see what the code is. Here I have this HTML file, top level HTML element, a body, a paragraph, hello, click the button, and a button. There's some JavaScript here. You don't really have to know JavaScript. I'll just break it down. Essentially, there's going to be, and we'll get into this in more detail when we talk about scripting languages, the browsers will provide some kind of API to manipulate the DOM. The DOM itself lives inside of the browser. Chrome has full ownership of the DOM, and it provides APIs to the various scripting languages to manipulate that DOM. So what we're doing here is we're saying, oh, let's create a new paragraph element. We'll give it the words tiki-taka, and we'll append it onto the body here. So then we say, hello, click the button. We have the button, and we'll just throw things onto the bottom of it. So this is very simple. Every time we click it, these appear. And now we have this DOM, which doesn't match the HTML file itself. So that's that's kind of, it's a shallow distinction, but that's what the DOM is and why people generally talk about the DOM versus HTML when they're talking about manipulating presentation that's on the screen. So CSS provides controls that style what we're looking at. So HTML itself, and really the DOM, describes what content is on the page. And CSS allows you to control how that content is presented. So let's do a quick demo here. Type with broken keyboard. Okay. So this page here is called CSS Zen Garden, and it's just kind of a demo of what CSS can do. It was probably more well known back when CSS was kind of a new thing. But it's pretty interesting. Basically, the idea is that there's a bunch of different designs here. All of these designs have the exact same HTML. So we can see like there's benefits here, H3 benefits, a paragraph, why participate, blah, blah, blah. Abbreviation, title, whatever, that's the HTML. And then there's different styles, which will give us, they don't change the actual HTML at all. So now we're still looking at the exact same HTML. All that's changed is the CSS style sheet that controls how that HTML appears. So we can still see there's this benefits section. It's the exact same DOM representation that we had before. But CSS rules control what gets shown. So just, so let's talk about a little bit about how that happens. In particular, I want to talk about selectors, because they kind of are useful even outside of CSS. So they were a concept originally invented to sort of make CSS manageable, and then they were so useful, jQuery originally made them available outside of CSS, so you could use them even inside of JavaScript, and eventually that got sucked into the standard DOM API as well. So in JavaScript, you also tend to use selectors a lot, and the basic idea of selectors is it is a query language for querying pieces of the DOM. So let's talk about what that means. Here I have this site, so let's go ahead and open it up. This is a list of books for Game of Thrones. Every other one is a slightly different color, and my intention originally was that the unfinished books would be colored red. So here is the HTML for it. I have my body, an unordered list, and then a bunch of list items. Notice that these two list items have a class unfinished. So then here in this style section, this is my CSS. And so here's a really basic selector. I say if it has the class unfinished, make the background red. And here's a slightly more sophisticated selector, which basically says every even child, make the background gray. And so what these selectors are doing is selecting a subset of my DOM that these rules will apply to. So any piece of the DOM that matches this query will get these style rules. And the reason my goal of having these two appear red didn't work is because both of these selectors match this item here. It's both even and it has the class unfinished. So CSS has to make a decision on to which one to apply. You don't really need to know how that works, but basically it tries to pick the most specific rule and apply that one last. So this is a more specific rule than this one, and how you define most specific, you can read a whole long document about it. You don't really need to know. Anyway, one of the interesting items here is this idea of a class. Any element in your DOM can have classes, and it's just a list of tags, basically. Class is a terrible word to apply to it. It has nothing to do with object-oriented programming. All of this is a list of tags, just string tags. And really the only purpose of this is to allow you to create rules. So here, when I created this HTML, I was able to put these classes in here so I could know I could style these things specially. So you'll see classes used a lot. So it's good to know what they are, and at least know that they have nothing to do with object-oriented programming. They're just a way of tagging parts of the document. And then I did mention that these selectors exist outside of CSS as well. So here I have a button, and when it's clicked, I'm going to grab all of the items with the .unfinished class. So again, this is a selector. I'm using the exact same selector here, and then I'm going to do something which you've probably read ahead by now. So I've got my reveal the truth, and it just turns out never going to happen. So I say I'll grab all of those unfinished books and make them never going to happen. So that's CSS. Semantic, this should be HTML. Semantic HTML is a term you'll hear thrown out there. It's kind of dying out in hype. For a little while, it had lots of hype behind it. And it was at one point in time called Web 3.0. We'll talk about Web 2.0 later. But the basic idea behind semantic HTML is that there may be more than one way to write something in HTML. In fact, there almost always is. So I have that example here with my unordered list and a bunch of list items. Here, I have this file. There's no unordered list. There's no list items. All I have is a bunch of divs. And a div is something that you will see a lot in HTML if you do any kind of HTML writing or manipulation. It basically means a element that has no other real style applied to it. There's two sort of generic elements. There's a div and a span. One of them has a block display, and one of them has an inline list display. Not inline list, a inline display. What that means you don't need to know unless you're going to do a lot of CSS and HTML. But basically div and span are sort of your generic whatever elements. So I said, okay, I'm just going to use generic elements, and I'm going to style them in such a way that it looks the same. So I can now open that, and I get the exact same thing. So I have two ways, drastically different ways of presenting the exact same HTML. So the idea behind semantic HTML is that just because you can doesn't mean you should. So semantic HTML would say that this way is worse and this way is better. By using the elements as they're intended to be used, you are communicating more information to tools. And the idea is that maybe it's not just the renderer that's going to be looking at the DOM. And so two good examples are accessibility and search engine optimization. Accessibility in particular, if someone went to go visit this site here and they were blind, then essentially they have screen readers which will read what's on the screen. And there's a lot of integration between browsers and screen readers to allow them to read websites in a meaningful way. So if you have this here, the screen reader will be able to present to the user and say, hey, there's a list on this page. Do you want to go into it and look at each of the items in the list? Yes or no kind of thing. And there's certain controls for going into a list. You can jump to the next thing. Whereas if I have this page here, it's just going to show as a bunch of text. And there's no way that the blind user would know that it's a list because there's no semantic content in here. And part of HTML5, which came out a while ago, was to add a whole bunch of elements that add that semantic content, but really act just like a div. So you have like article, nav, summary, aside, and these don't actually control how the element inside is displayed at all. They just sort of change the semantic meaning. So screen readers can use this information really, it's very useful. And then also search engine optimization. So when you view a site on Google, let's just Google for something. So we see a bunch of sites here. We get these little blurbs here. This blurb is taken usually from this summary element if it's on your page. So if you didn't use a summary, you just used a div, it wouldn't know and it might grab the wrong thing. Okay, so everything I've been talking about so far has been HTML and CSS. There are a few other options for presentation. Canvas is one of them. It's not, I say it's not really HTML. It gets embedded into an HTML document. So there is a HTML document, a piece of HTML called Canvas, but it's, for all intents and purposes, it's something separate. And the idea here is to allow efficient pixel level control of a page. So let's just take a quick look at an example here. So my HTML is in my body here. All I have is this canvas. I give it a width and a height, and that's it. And then in my JavaScript, I say I want to draw a red rectangle at XY position 100, 120 with a width of 10 and a height of 17. And so if we open up that, it should look exactly like what you think it will look like. A tiny little rectangle on the page. Now, that was a very simple example. You can do some quite powerful things with Canvas. So let's go ahead and take a look. So here, this is again, just using that canvas. So people often assume that with HTML, you can't really do any sophisticated graphics. But with that canvas, I can make this very cool, well, I can't make it, but someone made this very cool terrible cloth demo. And so this is all just using Canvas. Now, if you tried to do this with HTML elements, you'd have millions and millions and millions of little squares getting transformed with lots of CSS transformations and things like that. You could try, but you wouldn't be able to get the performance. So Canvas is something you use if you really need that 2D performance. So the obvious application is games. You'll see it used in a few other places, but mostly you're going to see Canvas used in games. Now, it's not even then terribly popular because in-browser HTML games is not necessarily that popular of a thing these days. Most games are going to be either mobile apps or they're going to be desktop applications, but it's still around. It's there, and you'll see it here and there. It's good for what it does, but it's going to be a lot lower level. You won't have a layout manager. You won't have all your nice fancy elements. You don't have all your CSS selectors. So it's definitely, if you're just throwing together a web page, it would be a bad idea to do it in Canvas because you're just going to end up doing a ton more work. And then finally, there is WebGL. And this is basically a way to get an OpenGL style interface in the browser. And this can do 3D graphics. You could conceivably do 3D graphics with Canvas, but you'd probably be better off at this point using WebGL because now you're going to be doing something that's much more closer to what you'd be doing if you're writing an actual desktop application where you're creating or loading in a 3D model, shoving it in. It's going to use the client's graphics card. So if they have a graphics card on their machine, it will use it. So again, that's another misconception, is that the browser never uses a graphics card. So let's look at a demo here. And so here, I have this field of grass, tons of elements, fancy graphics, running at 60 frames per second. So again, it's just another way to show that you can actually do pretty performant things inside the browser. Just because you're in a browser doesn't necessarily mean you have terrible performance and you can't do sophisticated graphics. Again, you're not going to see it that often because it's very low level, even worse than Canvas in some ways, and it takes a lot of work to be able to render anything in WebGL. And actually, I want to touch a little bit on this myth. So not only is WebGL going to use the graphics card, but actually both Canvas and even plain old HTML plus CSS, the browsers will use the graphics card where appropriate to help render what's being displayed on the screen. So your browser may very likely be using your graphics card as you're browsing the web. Okay, I didn't fit into 15 minutes at all, but that covers presentation. So next, I'm going to talk about scripting, then transport, and then start breaking down how web applications are actually developed. What are the frameworks out there, different approaches, architectures, and techniques. So if you enjoyed this, please stick around. If this was just super boring because you already knew HTML and CSS, well, hopefully the next videos will cover things that you didn't already know.